All right, let's get started then. So today we want to discuss polynomials, and this is a very crucial part of calculus, because then this is where we're going to sketch cubic functions. So the skill that we're going to do today, from factorizing cubic polynomials to solving for x, that skill is very important because we will need that in order for us to sketch cubic functions. So it will help us basically to be able to calculate the x-intercept. So loosely speaking, a polynomial p of x is basically an algebraic expression, okay? So let's say this is what? X squared, let's call that a3, x cubed, etc., up to maybe an xn. So it's just an algebraic expression in which, now this is the important part, in which the exponents, right, of your x terms, of the x terms, are positive integers. If you don't want to say positive integers, you may say whole numbers. All right, this is very, very important, okay? And of course, the highest exponent of a polynomial tells you the degree of the polynomial. Of course, the coefficients will be real numbers, and if real numbers can be set, so it is the case with those coefficients. All right, so we're just gonna focus on factorizing cubic polynomials. Cubic obviously suggests degree 3 or power 3. We could go to 4, which would suggest quartic there. We refer to those as quartic, but we're not going to get to that in the high school curriculum, at least. In further studies, we do get to do those. So few skills that we need then. We need to remember how to factorize cubes, sum of cubes or difference of cubes. We need to remember also how to factorize trinomials. But of course, at this level, in grade 12 level, you do have to your disposal the quadratic formula, which you then can also use to help you with finding factors or the roots of an equation, in the case of an equation. So let's see how this factorization works out. I'm going to start with a very basic one. So let's suppose for our first example, we have the expression x cubed minus x squared minus 12x. Of course, there's a polynomial because it does meet the definition of a polynomial. And we could call it a special one in a sense that it has 3 terms. So we could classify it as a trinomial since it has 3 terms. Anyways, we're not going to get to those nitty-gritties. One of the principal methods of factorization is factorizing using the highest common factor. So I would like to just emphasize this, that whenever you're going to try and factorize something, or you are being asked to factorize something, please, please, please always look out for the highest common factor. Students often miss out on this, and then they get it wrong. They wonder what went wrong when it was easy to factorize the sum. So I just need you to be on the lookout for the highest common factor at all times. In this case, I actually have a highest common factor, and it is x. So I'll be left with x squared minus x minus 12. And then the next thing that you want to check is this thing factorable? Can I factorize x squared minus x minus 12? And then I think, yeah, if your factoring is good, you will realize that you can actually factorize it. But if you did not see that, then this is what you can do. And I mean, I know there's a bad habit, but look, you out there looking for marks. So what you could do is you could substitute this in the quadratic formula. So remember, the quadratic formula works out for solutions to the equation ax squared plus bx plus c is 0. So obviously, if I have x squared minus x minus 12 equals to 0. It means that a is 1, b is a negative 1, and c is a negative 12. So then, if I go into the quadratic formula, it means the substitution would look like this. Okay? And I actually want you to see how that's going to work, if my calculator will allow me. Let's see. Let's see if I can get this up running. I just have to do this. Okay, let's see. It should come up. Great. So if I do this on the quadratic formula, I think we said that b is a negative 1. So if I punch that, and then I have the square root of b squared minus 4ac is a negative 12, then over 2 times 1. You see, the quadratic formula gives me a solution. It means that x is equal to 4, right? Or x is equal to what? Let's check. So for the minus, I just got to put a minus in front of the square root. So, or x is a negative 3. Now, what does this mean? If you think of solving an equation for x and you have factorized, if x equals to minus 4, then that means you had x minus 4 equals to 0. And if x is equal to negative 3, it means you had x plus 3 equals to 0. Now, this simply means x minus 4, x plus 3 are your factors. And that's exactly what we have here. That's exactly what we have here, x minus 4, x plus 3. So if it is a struggle to factorize at grade 11 and grade 12 level, you can do this. In grade 10, it will be unacceptable, obviously. So you need to actually know the ways, the methods for factorization. Actually, problems of factorization, the problems that are there in grade 11 and 12 are a result of not learning factorization properly in grade 10. Okay, so this will be it. And it makes sense because I've got degree 3, so I'm expecting 3 factors. And so that is complete. Another one, and I want to put this one deliberately because this is the sum of cubes. What we learned is that we're going to cube root this first expression. So when I cube root this, I get 2x. I bring the sign between the two terms and I cube root the 1, I also get a 1. Then to generate the second bracket, I must square the 2x. Now be careful. Squaring 2x means raising the entire thing to the 2. So that becomes a 4x squared. Then we said this sign must be opposite. So because I've got a plus here, I'm going to have a minus here. And then I take the product. So I multiply the 2x by the 1. So that's going to be 2x. And then lastly, and take note, this last term will always be a positive because you are squaring. So whether it's a negative or not, when you square negative, it becomes a positive. So this is how we do the sum of cubes. This is the strategy. This is the process. But this is not the only case. Sometimes you may reach a situation where you have to sort of factorize by grouping. Let's have a look at an example where we have to factorize by grouping. So I've got an x cubed plus x squared minus 4x minus 4. Now we know you apply grouping when you have 4 or more terms, right? So the usual instinct or the normal thing to do is you just want to look for the highest common factor between the first 2 terms. And that is an x squared in this case. Then I get an x plus 1. Then you kind of take an intellectual guess that you got to have an x plus 1 when you factorize these. So the question now is, if you were to multiply something by this x plus 1, what should that something be so that you get a negative 4x and a negative 4? And I'm pretty sure you will see that it is an x. I mean, it is a minus 4. Because when I multiply minus 4 by x, I will have a minus 4x. And when I multiply minus 4x by a positive 1, I will have a negative 4. Then we're going to then factor out the x plus 1 as our common factor, and I'm left with x squared minus 4. And again, I ask the question, can I factorize an x squared minus 4? And the answer is yes, I can, because this is difference of two squares, right? So x plus 1, and then we go x plus 2, x minus 2. Or if you want to start with the x minus 2, that is still fine. Now, unfortunately, in grade 12, you will not always get nice factorable trinomials or polynomials rather of degree 3 like the ones I have just shown. Sometimes things will get a bit tough and you're going to have to actually try and figure out what should be the factors of that polynomial. It will not be quite obvious, but we've got a strategy for this. So to get to this, we're going to discuss two important theorems. The first theorem is the remainder theorem, and you don't have to worry about proving this. You don't need to know the proof. You just need to know what it says and what the meaning thereof is. And then, having spoken about the remainder theorem, we will then discuss the factor theorem. And the factor theorem is essentially an extension or a special case, I must say. It is actually a special case of the remainder theorem. Now, what does it say? This is what it says. If I've got a polynomial f of x and I divide it by some other polynomial x plus a, so watch this. When f of x, which is a polynomial, is divided by x plus a, the remainder is actually f of minus a. Now, this may sound really strange and abstract. You may be like, but what's going on here? Well, let's give you an illustration. Suppose I've got a polynomial f of x given by x squared plus 6x plus 9. And this thing, f of x, is divided by x plus 2. Now, what does the theorem say? So let's actually take this question as a question that says, determine the remainder when polynomial f of x is divided by x plus 2. So this is what it is saying. It is saying, if I take x plus 2 and I equate it to 0, I will get x equals to minus 2. So it means that f of minus 2, or the theorem says f of minus 2 is my remainder. So what is f of negative 2? All right. So now this is 4 minus 12, which is going to be a minus 8 plus 9. I think it's a 1. So the remainder is a 1. That's it. Okay. So that is basically what the theorem says. Now, sometimes what happens is you don't get to divide by a nice linear factor like that. Sometimes it happens that you have f of x divided by, let's look at this one, by bx plus a. So in this case, you will have to again sort of solve for x. So I hope you notice that if I solve for x, then I have a negative a over b. And in this case, then, the remainder will be f of negative a over b. So for example, I could give you 2x plus 1. So if I give you 2x plus 1, it means f of negative 1 over 2 will be the remainder. Now, the concept of remainder is very important because we're going to do long division, and it is long division where sometimes we get a remainder. But then in a case where we do not get a remainder, in other words, the remainder is 0, then that's where the factor theorem comes in. So, and you'll understand why I say the factor theorem is a special case. So let's look at the fact that the remainder theorem. The remainder theorem says, if I divide a function by a linear factor or a polynomial by a linear factor, then the remainder is basically the root of that factor, is the root of that factor substituted into the polynomial. Now, the factor theorem says, if it so happens that you are dividing f of x, so f of x is divided by, let's take again, maybe ax, let's take again bx plus a, okay? So it says, if it happens that this remainder is a 0, then our conclusion is this bx plus a must be a factor. It is a factor of the polynomial. And we are doing this because we want to be able to do this whole thing here called factorization. And remember, I said to you, we will come across situations where it is not so obvious to factorize, okay? And this is where these two beautiful theorems come in, because they kind of guiding us. They are telling us how we can kind of at least start, you know, when in the process of factorization, wherein the factors are not so obvious. So if, I mean, a typical example of the factor theorem could be show that something is a factor of something. All you have to do is to substitute. And then if you get 0, you will conclude that it is a factor. All right. So these are two things that I need you to understand. They are not really separate things, as you have seen, that the factor theorem is just a special case of the remainder theorem, because it says, it essentially says, if you apply the remainder theorem, if you try and find the remainder of a polynomial when dividing it by a linear factor, if you do that and the remainder is 0, the factor theorem is essentially saying, then that linear factor is essentially a factor of the polynomial. Okay, now let's get to this. Let's get to this. Let us see how this plays out. I'm going to show you the inspection approach before I rush to the long division. Actually, for today, I just want you to do the inspection approach because I tend to believe that it works quicker than the long division. Only when really you are desperate for long division, then will I show the long division. So look at this question. The question says factorize x cubed plus 5x squared minus 2x minus 24. So this is where you're gonna try grouping, and grouping doesn't work, and you'll be like, oh man, I was taught junk and all that. No, that's not the case. All right, you are taught well. It's just that that method doesn't work here. So what are you gonna do now? Well, fear not. This is what you're gonna do. You're gonna look for factors of 24. All right, you're gonna look for factors of 24, and you're gonna substitute them into this polynomial. So let's call this polynomial f of x. You're gonna substitute them there. And if one is a factor of 24, please take note, you will test positive 1, you will test negative 1. If 2 is a factor of 24, you will test positive 2 and a negative 2. If 3 is a factor of 24, you will test for positive 3 and a negative 3, and so on and so on. So let us actually do that testing. Let us see what f of 1 is. And this is a point where I would actually ask you to try out your calculators. I want someone to try f of 1, someone to try f of negative 1, someone to try f of positive 2, and someone to try f of negative 2. Let us try that. What are you doing? You are simply substituting 1 into this polynomial. I believe some of you know what's going on here. So please do that. Help me out with that substitution. So here I have, I think this is going to give me 1 plus 5 is a 6. Then 6 minus 2 is a 4. So this is going to give me a negative 20. So the remainder is not 0. The remainder is a negative 20. Therefore, I will say, look, you said you tested x equals to minus 1, right? So that means x minus 1 is not a factor. So x minus 1 will not feature in our factorization. I'm hoping someone tried x plus 1. Is there someone who tried x plus 1? Who do I have there? Anyone who's tried x plus 1, you can text. If you are shy to talk, you can just text. Tell me, is x plus 1 a factor or not? Yes or no? And then while you are doing that, try f of 2. So try x equals to 2. In other words, substitute 2. And again, tell me whether it's a factor or not. Who's going to do this? Who's tried out what?
F of 2 is a factor.
Okay, f of 2 is 0. F of 2 is 0. Am I getting that right? So if I heard you correctly, you are saying f of 2, when I substituted 2, two, I get a 0. Therefore,
yes.
Thank you. Therefore, x minus 2 is a factor. Now, this is good. This is a breakthrough. What does it mean then for x minus 2 to be a factor? Well, it means I can rewrite my polynomial in terms of x minus 2 as follows. So f of x squared, sorry, this is an x cubed. So now I have x cubed plus 5x squared minus 2x minus 24 equal to x minus 2 times something. And this is the exciting part for me. This is where I'm going to show you how to find this something here by inspection. And by the way, this is going to be a trinomial because we have a cubic here. When you factorize a cubic, one factor can be linear and the other can be quadratic. Now, sometimes the quadratic can be factorized, sometimes it cannot be factorized. So it is always important to actually assess whether that quadratic can be factorized, and we're gonna do just that. Let's start here. This is how inspection works. Everyone, I need you to pay attention now. Okay, so I'm gonna write here in green, I'm gonna write my actual polynomial. So my actual polynomial is x cubed plus 5x squared minus 2x minus 24. Now, obviously, if I FOIL, or not foiling here, if I distribute, so if I multiply x, the question is, what should I multiply this x by to get an x cubed? So I'm sure everyone agrees I must multiply it by x squared. And the next question is, what should I multiply the negative 2 by? Please take note, I am considering the signs in this thinking process. So what should I multiply negative 2 by in order for me to get a negative 24? And I hope everyone is thinking a positive 12. It can't be anything. It has to be a positive 12. Now, I said to you, this thing is going to be a trinomial. So that means, remember, your trinomial is typically ax squared plus bx plus c. So I have the squared term, I have the constant term. It means I am missing a middle term. So let's call it a bx term. So I'm missing a bx term in the middle. And we're going to find this term. And this is our thinking process. Watch this. This is what I love about this method. Now, I'm going to multiply all terms that I'm going to give, that are going to give me rather an x term. Okay, so I will note that if I multiply x by a 12, I'm actually going to get an x term called 12x. And I'm also noting that at the same time, and I think this is the other important part, right? If I multiply this by that, I hope you notice that's also going to give me an x term. Let's also do more multiplication, because remember, our idea here is to actually find out, hey, what is this missing b here? Okay, so let's try the squared terms as well. Actually, you can do it in two ways. You can do it in two ways. Okay, this is one way. If you don't like the x terms, you can try the squared terms. And I want to show you it works both ways. So if I try the squared terms, a negative 2 times an x squared is going to be a negative 2x squared. And then where else can I get a squared term? Well, surely I will get an x squared term when I multiply x by that bx. You see that? So that's what I'm getting. Now, why am I bringing this? Because I need you to see something. Some students think there's only one way to do this. And sometimes when they don't see that way, they be like, nah, this ain't working. Now, this is the nice part now. This 12x minus 2bx should give me what? If you think with me here, please, it should actually give me that middle term. And what is that middle term? That middle term, oh, sorry, it's not really middle, but it must give me that x term. That x term is a minus 2x. So I just want to write it here. And we had a minus 12x minus 2bx. And this must ideally give me a negative 2x. And this has to make sense, because remember, we are saying when this polynomial is factorized, it means when I multiply back the factors, they have to give me the original thing. So this is the inspection part, and this is where things become a bit interesting. So I'm actually gonna join my like terms here, and then when I do that, is this a bx? Yeah, I think that's a bx. So that's a 12. And then what am I getting now? Is this going to be a 10? I think I'm missing something here. So does that mean b is a negative 5? No, that's actually not right. Eh? I wonder what I'm missing here. Is someone checking with me there? Let me just see if I did not confuse my multiplication here. I don't think I did though. So let's try that again. My x terms. Oh, guys, you let me get this wrong. You see what I got wrong? I said minus 12 instead of positive 12. Now this is going to make sense. It should be a positive 12, guys. So that's why I went wrong. And then this one, minus 2bx. Yes. Now, what should this give me? A negative 2x. Now, minus 2bx is equal to minus 14x. And when I divide, watch what I'm going to do here. I'm going to divide by negative 2x both sides. Then I have b is equal to, obviously, a positive 7. And I want to show you that you could get a positive 7 if you used the squared terms. Okay, let me just see that I didn't mess up the signs here. Okay, I do have a negative 2x squared. Yes, that makes sense. And I have a bx squared. Okay, it looks like I didn't mess up on this one. So this must give me what? If there's someone following, what should negative 2x squared plus bx squared give me? What should it be equal to? Are you there, guys? Okay. Is there someone giving me an answer there?
4x.
Come again? What should the squared terms give me? Look at the original, the one in green. Well done. It must give me 5x squared. Thank you. So it must give me 5x squared. So now bx squared will be equal to, so I'm adding like terms, will be equal to 7x squared. Then I divide by x squared here, and you see I still get b is equal to a 7. So you don't have to do both. You just have to choose one. If you prefer working with the x terms, it's okay. Choose the x terms. If you prefer working with the squared terms, it's fine. Choose the x squared terms. But the bottom line is this. We have found the trinomial. It means then we can do the following. We can say, well, x cubed plus 5x squared minus 2x minus 24 is equal to x minus 2 into x squared plus, remember b is a 7, so plus 7x plus 12. That's what it means. Now, I said to you, sometimes this thing is factorable, so we're going to check, is this factorable? Actually, looking at it now, it does appear that it can be factorized. So let's factorize further then. I'm just going to write it in a different color now. If I factorize this trinomial, it's going to be x plus 4 into x plus a 3. So it's always actually important to check whether what you get there can be factorized or not. And look at this. Bravo. We have finally factorized this cubic polynomial. All right. Now, if this is still unclear, I am more than happy to do a second example. And that's what I'm about to do right now. Let us go for it. We're going to take now another one. And excuse me. And as we do this one, we're going to try, I think we're going to try inspection again here. Yeah, I don't want to do long division as yet. Don't want to try do long division. Okay. Now, the one that I'm going to try is a special one. And what makes it special, and I want you to take note here, what makes it special is the fact that, let me use g of x. What makes it special is the fact that the coefficient of the cubic term is not a 1. I want you to notice here that the coefficient of the cubic term is a 1. So this cubic term here, it has a coefficient 1. Now, I want you to look at an instance where the coefficient is not 1. So let's look at the example. 2x cubed plus 3x squared plus 4x minus a 3. So surely the coefficient of the cubic term is not 1. So what do we do in this case? Do we still just take positive and negative factors of the constant term? No. Here, this is what we're going to do. We're going to take factors of, watch this, we're going to take factors of the constant term divided by the coefficient of the cubic term. So these are the factors that we're going to take. And it's going to be an interesting one, isn't it? So we will have to see how this works, how this plays out. All right, what are the factors now? We got to be very delicate about this step. So the factors of 3 over 2, obviously 1 over 1 will be in there. And we're going to try, obviously, both positive and negative, right? We know that one, standard procedure, both positive and negative. But then the nice thing about this is both 2 and 3 are prime numbers. So you're not really going to have a lot of options. So again, that's my second option. I could have that. Then my third option would be, watch this now, 1, and then I've changed factors of the denominator to 2 now. So again, I'm going to try plus minus, and then I'm also going to have the combination of plus minus 3 over 2. So we've tried to really make it easy. If you notice, let me repeat what I said. We're looking for factors of 3 over 2. But how we're going to do it is really simple. Factors of 3 are just 1 and 3. Factors of 2 are just 1 and 2. So I just take the different combinations of those factors whereby one is numerator, the other one is in the denominator. So somebody help me here again. Obviously, this will simplify to a 1. So somebody please go ahead, try plus minus 1. This one will simplify to a plus minus 3. So somebody please go ahead and try that for me. This one here stays as plus minus a half. So try a positive half, then a negative half. And if that still fails, we will have to try as our last resort a positive 3 over 2 and a negative 3 over 2. So somebody please try and substitute that. So obviously you're substituting into this whole thing here, into g of x. And you must use brackets, please. You have to use brackets in your substitution. So in your calculator, you're having something like this. Then you're going to put your factor there, cube it like that. Same thing here, square it like that. Same thing here, and then that. So I see something has tapped here as that. Plus 1 is a 6, so that means if plus 1 is a 6, it means x minus 1 is not a factor. So let's try negative 1. Someone is trying this. I like that. Negative 1 is minus 6. So that means there's no hope here. We are xing this. This is not going to help us. So we're moving on to plus and minus 3. Let's go. Keep trying. I like those responses. Shows me that you are engaged. So well done. Somebody try a plus 3. Somebody try a minus 3. And somebody try a positive half. Somebody try a negative half. So let's see. Plus 3 gives us a 90. So we're still not there yet. We want to try a negative 3 now. What does that give us? A negative 3. A negative 3. Oh, well, Tabang says the factor is a positive half. Okay, Tabang, just be careful how you use these words, okay? So x equals to a half produces remainder 1. That means x minus a half is a factor. But Tabang, let's just be careful. This is what we're going to do, right? So since x equals to half, and we want to have this as a linear thing, as a linear factor, I'm going to multiply by 2 both sides. So 2x minus 1 is a factor. So that's the right way. That's the correct approach to get that. But I kind of get what you mean. Yes, Lube, negative 3 will not work as well. So we have established now that a positive half works out. So we are good. We know that g of half. So when you substitute a positive half, you're going to get 0 as your remainder, which then means, please note this little process that I've written down here, which means that 2x minus 1 is a factor. Now, we know what that means, right? If 2x minus 1 is a factor, it means that we can write 2x cubed plus 3x squared plus 4x minus 3 as 2x minus 1 times some quadratic. Now let's go into the process of finding that. I need to multiply 2x obviously by an x squared so that I can get this 2x cubed. I also need to multiply the negative 3, sorry, the negative 1. I want to get a negative 3, so I got ahead of myself here. So I will multiply a negative 1 by a positive 3 to get this negative 3 here. I hope we are together so far. Then I know that the middle term will be some bx. Now, in the polynomial that is given, I do have the squared terms and the x terms. So I have the x squared terms and the x terms both given. So I won't do both ways in this case. I'm just gonna decide which one I'm gonna take. I think I like the 4 there that I see. So I'm gonna go with the x terms. So how do I get an x term? By multiplying. Okay, Lisa, thanks for letting me know that I was not audible. I just realized that now, but I hope you got what I was saying. I was just correcting. I had written a -3. I had written a -3 and a 4x. I don't know where I got that, but that was not the case. Okay. So thanks for bringing that, guys. If I'm not audible, just let me know. Usually that is a result of my microphone or one of my microphones turning off, so I have to put in another one. So thanks. Once I cut, let me know. All right. So I was saying I'm gonna do a third example. I'm going to do a third example, and that will be the last example for the day. I hope you all still with me and you can hear me. Right. So the last one is going to be, let's take this one. H of x equals to x squared minus 3x plus 2. Let's take this one. And what I notice here is that it's not x squared, sorry. I mean, this one you can do by the quadratic formula, so it must be an x cubed. Yeah. Now, here I notice that there is no squared term. So it should be like this. Yeah, there's no squared term. Okay. So in other words, this is what is happening. You've got x cubed and the squared term actually has a 0 coefficient. That is exactly what is happening. So for those of you who prefer using the squared term to find the coefficients or to find that b, this b here, if you prefer using the squared terms to find the b, it means when it comes to this one, you have to equate those to 0. Okay, just beware of that. Right, and I think I'll do it both ways. Okay, who's gonna figure out our root here? What is the root? In other words, what would be the number that gives us the remainder 0? So what should we substitute in here to get a 0 as the remainder? So I'm sure you know by now the drill. I mean, I've got a 2. So there are only, what? 2, 1 and 2. So plus 1 minus 2 plus 2 minus 2. Please try that for me and let me know what you get. Tell me which one is going to work. You can type it in the box there, in the chats. Do I have a winner? Okay. Okay, Taban got a 2. All right, Taban, that's fine. Let's say, so Taban says x equals to 2 produces remainder 0, which means x minus 2 is a factor. Now, someone is also saying something there, -1 from Lelo. And this is the interesting part then about this sum. So if you get all that, it means you don't actually need to go the long route of inspection. So if we now have another answer that says x equals to -1 is a factor, it means x plus 1 is also a factor. So just like that, we have 2 factors already, which now kind of, well, we are done in essence. It means we can write h of x, or maybe let me not just do that. So you see you found 2 now. So let's go with that. I'm going to go with what you found. So it literally means that you can already factorize this thing into x plus 1, x minus 2. You see? That's what it literally means. Now, the question is, what should be the third factor? That is the question. What would be the third factor? Now, to find the third factor, there are 2 ways to go about it, obviously. And I think we kind of made it complicated by trying to do both factors here. But let's see, how do you get away with it, even if it's this complicated, right? You never know. So let's just try it out. Or, no, maybe not. I think it's a bad idea. Might confuse you more. So let me save you that. Let's stick to our method. So I'm just going to take one of the factors. Let's take, we have taken what right now? Let's say we did not see. Tabang, you started with a bigger number, with a bigger factor 2. And maybe let's try that. I'll try it with Tabang's way and I'll try it with Lelo's way. So let's just stick to using one factor, right? So that I don't cause confusion. Then this is x squared. We know, I hope everyone is aware now how we get the x squared. And I'm going to need a plus 1 here. And I hope everyone is aware of that. And we know there's a bx somewhere in the middle. Now, it's up to you still whether you want to play with the x squared terms or the x terms. So if you play with the x squared terms, then that is bx squared, and this is negative 2x squared, and this has to be a 0 because the squared term has a 0 coefficient, or there's no a squared term there. So that's the nice thing in this case. So we then get bx squared is equal to 2x squared. So this simply means b, does this mean b is equal to 2? That's what it means. So b is equal to 2. We're going to take b is equal to 2. Now, let's substitute back. Therefore, x cubed minus 3x minus 2 is equal to x minus 2 into x squared plus 2x plus 1, which means we have x minus 2. Watch this now. This can actually be factorized. It's what we call a perfect square trinomial. It can be factorized into x plus 1 all squared. And this x plus 1 in cubic functions, it is actually, it's very interesting because it is going to be, you will see when we sketch, it's going to be both an intercept and a turning point. This is what we refer to as a repeated root as well, just to get you thinking ahead. So when this often happens, you will see there's going to be a turning point at a -1, but that turning point will also be an x-intercept. So more on this in our next section when we do cubic functions, or when we sketch those cubic functions. But that's about it. Let's see, would I get the same answer if I used Lelo's method? So let's say we found that x plus 1 was the thing. So we start x plus 1. So this will be x squared. And I know I've got to have a bx here. And then I need a -2. So I'll have a -2 here because 1 times -2 is that. And let's still use the squared terms. Let's still use the squared terms. So that's how I'm going to get my first squared term, by bx squared and then plus x squared. But we know it's going to be 0. So it means bx squared, excuse me, it is equal to a negative x squared. Please take note of that. And in that case, it would simply mean that b is a -1 in this case. Now, let's write the final answer. So x cubed minus 3x minus 2 is, watch this, it is an x plus 1 into x squared minus x minus 2. And if you, again, whether you check with the quadratic formula or you know your factorization, you realize that this will actually be an x plus 1 into an x minus 2. And it does give us the same result that we had there. So both ways would still work. So well done to both of you. I'm just saying, don't panic. There's no need to panic if you feel like you got a wrong factor and someone else got a different factor. As long as you know that you got a 0, the remainder was 0 when you substituted that number, then rest assured you will arrive at the same conclusion. All right. So we're going to leave it here. And maybe what we will do next time is we will maybe do a bit of advanced questions before we get to do what you call cubic functions or polynomials. All right, that will be about it. And yes, cheers, guys. Thanks for tuning in. Well done. And thanks for participating as well. See some of you on Wednesday, but then everyone else, let's meet again next Sunday and continue on this. Cheers.